Okay, we'll get back to section 10.3 here. We're talking about polar graphs. We did these two problems. Let's see, in the last video we did problem 8. R equals 1 plus sine theta. So let me show you a couple more of these graphs here. Now what we're doing is we're graphing these 12 curves, and let's see, so we're on problem 9 here, and R equals 3 plus 2 cosine theta. Okay, so again, you know, like a lot of these graphs will be symmetric to either the x-axis, the y-axis, or the origin, or the polar axis, the line theta equals pi over 2, or the pole is what it's called. Let me just start with using a table of numbers. And so if theta is 0, cosine of 0 is 1. 3 plus 2 is 5, so R is 5. Okay, so 5, 0 is on the graph. Remember, you're graphing the points R theta, not theta R. Okay, so 5, 0. If we let theta be pi over 6, cosine of pi over 6 is root 3 divided by 2. Okay, times 2, the 2's cancel. Root 3 is about 1.73. So then if I add 3 to that, I get about 4.73 for R. Okay, so on the pi over 6 radial line, I need to go out 4.73 units and plot a point there. Okay, and then if theta is pi over 3 units, cosine pi over 3 is 1/2, times 2 is 1, plus 3 is 4. Okay, so on the pi over 3 axis, I need to go out 4 units and plot a point. There's that point there. And then I'm selecting pi over 2 next. Cosine pi over 2 is 0. R is 3. Okay, so on the pi over 2 radial line, I need to go out 3 units and plot a point. And then I'm selecting 2 pi over 3. So cosine of 2 pi over 3 is negative root 3 over 2, right? Because you're going into quadrant 2 there. So the adjacent side would be a negative. Negative root 3 over 2, the 2's cancel. So I'm looking at 3 minus root 3. Again, root 3 is about 1.73. So if I take 3 minus about 1.73, I get roughly about oops, sorry, I'm looking at the wrong one. So if theta is 2 pi over 3, yeah, that'd be the same thing as the angle pi over 3, but just flipped over into quadrant 2 there. And so instead of the adjacent side being 1, it's going to be a negative 1. So negative 1/2 will be the output value there. Negative 1/2 times 2 is negative 1, and 3 minus 1 is 2. Okay, so on the 2 pi over 3 radial line, you need to go out 2 units and plot a point. Okay, and then I'm selecting 5 pi over 6. So cosine of 5 pi over 6, that's negative root 3 over 2. You can cancel the 2's there, so we're looking at 3 minus root 3. Root 3 is about 1.73, right? So we get about 1.27. Okay, so on the radial line, 5 pi over 6, let's see, I guess I don't have that point plotted, but I need to go out about 1.27. Okay, so that's going to put me about right there. Okay, and then I'm selecting pi. Cosine pi is negative 1. If 3 minus 2, then would be 1. Okay, so on the pi axis, I need to go out 1 unit. And here's what I've got so far. Okay, so the next thing is maybe I'm wondering, you know, just to save time with this table and selecting points, you know, maybe is this graph symmetric to the x-axis or the polar axis? Well, to check that, I need to replace theta by a negative theta and then check and see if I get the same equation. So I'm doing that down here. The cosine function is an even function, right? So cosine of negative theta, that's the same as cosine theta. And so if I replace theta with a negative theta, that's the same thing as I originally have here. 3 plus 2 cosine theta. So that tells me that this graph is going to be symmetric to the polar axis. Okay, the x-axis. So I go ahead and draw the rest of this curve, okay? And now this curve is an important curve called a lemmason. Cardioids and lemmason, like cardioids are a family member of the lemmason family. Okay, so when we take a look at another example here, and then I'll talk about the difference between cardioids and lemmasons next. So problem 10. Let's see, I got R equals 1 plus 2 cosine theta. Okay, so if theta is 0, cosine 0 is 1. 1 plus 2 is 3. Okay, so 3, 0, that point would be on the graph. That's right there. Okay, and then I'm selecting pi over 6 next. Cosine pi over 6 is root 3 over 2. The 2's cancel. Root 3 is about 1.73. Plus 1 gives me 2.73 roughly. Okay, so on the pi over 6 radial line, I need to go out 2.73 units and plot that next point. If theta is pi over 3, okay, cosine pi over 3 is 1/2. Times 2 is 1, plus 1 is 2. So we need to go out 2 units on the pi over 3 radial line, plot that next point. If theta is pi over 2, cosine pi over 2 is 0, which means r is 1. Okay, and the point 1 pi over 2, that point would be on the graph. Okay, and then if theta is 2 pi over 3, cosine of 2 pi over 3 is negative 1/2, right, because you'd be in quadrant 2 there. The adjacent side is negative 1. Negative 1/2 times 2 is negative 1, plus 1 is 0. Okay, so on the 2 pi over 3 radial line, I need to go out 0 units, so that's going to put me right at the pole. Okay, and then the next one I select is 5 pi over 6. Okay, so cosine of 5 pi over 6, that's negative root 3 over 2, times 2 is negative root 3, plus 1, well, let's see, root 3 is about 1.73, right? So negative root 3, that'd be negative 1.73, plus 1, I'm looking at negative 0.73 as the R value. Okay, so on the 5 pi over 6 radial line, I need to go out in the opposite direction, 0.73 units. Okay, and plot that next point. So I'm in quadrant 4. And then I'm selecting one more value here. If theta is pi, cosine pi is negative 1. 1 minus 2 is negative 1. So on the pi axis, I need to go out to the right 1 unit and plot that next point. Okay, so again, points have many different ways to write them, you know, in polar coordinates. So like pi 1, that's the same thing as negative 1 pi, that's the same thing as 0, 1, right? So, okay. Now this curve, maybe I'm checking to see if now there's symmetry to the polar axis, okay, or the x-axis. So if I replace theta with a negative theta, by the way, any function involving just the cosine curve is always going to be symmetric to the x-axis, right? Because cosine of negative theta, that's the same thing as cosine theta. All right, 1 plus 2 cosine theta, that's what r is. So, you know, I can draw the rest of this curve here, knowing that it's symmetric to the polar axis, okay? And the type of curve that I have is a lemmason. Now this was a lemmason also, but this one has a loop in it, okay? And here's the difference between cardioids and lemmasons. So you have to be in the form a plus or minus b sine theta or a plus or minus b cosine theta for you to have a cardioid or a lemmason. So, you know, because like this one here is a plus b cosine theta, like I could know right away that I'm going to have a cardioid or a lemmason that I'm drawing, okay? So you're going to have a cardioid if a is equal to b. Well, that's what we had in problem 8. So a and b are both 1, and I have a cardioid, which means that there's a sharp turn right here at the cusp, okay? And you're going to have a lemma on whenever A is bigger than B. Okay, so like A is 3 and B is 2. Okay, so I'm going to have a lemma on, and there's a nice smooth turn through this point here. Okay, and you're going to have a lemma with a loop in it whenever B is bigger than A. So the B value is 2, the A value is 1. And by the way, the bigger the B value, the bigger the loop. Okay, so if I were to graph 1 plus 3 cosine theta, I'd have a bigger loop in this than I did when it was 1 plus 2 cosine theta. Okay, so cardioids and lemma, those are very, very important when it comes to polar coordinates. Okay, and ideally, we should recognize when we have a cardioid or a lemma. Okay, like if I'm in this form, like I should just know, it's going to be a lemma with a loop. Okay, just because the reason is again, certain equations will come up over and over and over again. Y equal x squared. Okay, we know the graph of y equal x squared. That's a parabola, right? And okay, so what I'm saying here is that in polar coordinate form, if you have a plus or minus b cosine theta, you can know right away that that's going to be a cardioid or a lemma. Okay. We try problem 11 here next. We got r squared equals 4 times sine 2 theta. Okay, so I'm going to set up a table of numbers here and select some theta values. So if theta is pi over 6, let's see, sine of 2 times pi over 6, that'd be sine of pi over 3, which is root 3 over 2, times 4, that's 2 root 3. Okay, so r squared equals 2 root 3. When I take the square root of both sides, don't forget the plus and minus there, I'm getting roughly about 1.9, if I go nearest one digit. Okay, so on the pi over 6 axis, go out 1.9 units and plot a point, and also go out negative 1.9 units, or in quadrant 3 there, and plot that other point. Okay, and then what if we let theta be pi over 4 next? Okay, sine of 2 times pi over 4, that'd be sine of pi over 2, which is 1. So r squared equals 4. That means that r would be 2 or negative 2. Okay, so on the pi over 4 radial line, I need to go out 2 units and plot a point. And also I need to go out negative 2 units and plot that other point there in quadrant 3. If I select pi over 3 next, okay, I'm looking at sine of 2 pi over 3, that is root 3 over 2. Okay, the opposite side would be root 3, right? So root 3 over 2 times 4, that'd be 2 root 3. R squared equals 2 root 3, means that if I take the square root of both sides, I got plus and minus 1.9 roughly. Okay, so on the pi over 3 radial line, I need to go out 1.9 units and plot a point. And also I need to go out negative 1.9 units and plot a point. So I'll be in quadrant 3 then. If I let theta be pi over 2, pi over 2 times 2 is pi, sine pi is 0. Okay, so r squared equals 0, that means that r is 0. So on the pi over 2 radial line, I need to go out 0 units, and that's going to put me right at the pole there. Okay, and so then if I draw this curve, okay, I'd have a lemniscate. Okay, by the way, I can know that I'm going to be symmetric to the origin, because if I replace r by a negative r and I get the same equation, I'm symmetric to the origin. Right? If I replace r with a negative r squared, the same as r squared. Okay, so I could know, before I even made this table, that I'm going to have something that's symmetric to the origin. Okay, and a lemniscate is like a figure 8 type curve there, and that's an important curve in polar coordinate form also. Okay, we have one more problem here, and then I was going to talk about just a few special polar graphs to know. Here's a worksheet that you should have, and here's the back side of that. And yeah, we'll look at this then in the next video. We'll do that. Okay.